Hey guys, welcome back to another video. In this video I am taking Fourier Transform of Unit 2. So we have a new topic over here, differential under integration sign, that is DUIS. I have taken one sum, so I will explain you all this topic inside the sum. The question is, find Fourier sine transform of f of x, and the f of x they have given over here is e raised to minus ax upon x. So what they're telling us over here is to find Fourier sine transform. That is, we have to find FST. So FST is, we have to they have given f of x, so we have to find fs of lambda. So the formula is integration of 0 to infinity f of x into sine lambda x into dx. So this is the formula. Now we have to substitute the value of f of x. This value we will put in this place. So integration of 0 to infinity e raised to minus ax upon x into sine lambda x dx. Now in this sum what we have to see is, in the if you see in this part we have 3 x terms. This is the first term, this is the second term, and this is the third term. Now when we have 3 x term, we cannot use u into v rule, so therefore we have this DUIS formula. So in this what we have to do is, they have given us one formula, we have to take derivative on both the sides. In this sum we have to take a derivative on both the sides, and we will take with respect to lambda, because we have 3x, we have only one lambda, therefore we will take with respect to lambda. So we'll take differentiate on both sides with respect to lambda. So d by d lambda into fs lambda is equal to integration of 0 to infinity, then we have all this part on x. Now we have to take differentiate. So this part we cannot differentiate because this does not have a lambda, only this has lambda, so therefore this will get differentiate. So d by d lambda of sine lambda x dx. So then this will remain as it is. It will be 0 to infinity e raised to minus ax upon x, and derivative of sine lambda x with respect to lambda will be cos lambda x. It will be into x because this is derivative. If it was integration, then x would come in denominator, then dx. Now this x and this x will get cut. Now what remains is integration of 0 to infinity e raised to minus ax into cos lambda x dx. Now this, if you remember, it is the formula of e raised to x into cos lambda x. If you remember the formula, the answer to this is e raised to minus ax upon a square plus lambda square into minus a, because a into, we have cos over here, so cos lambda x plus lambda sine lambda x. So this is the formula, and the limits we have to put, the limits are from 0 to infinity. So then first we'll use upper limit and then the lower limit. So in place of x we have to put infinity, because this is with respect to x over here. So then e raised to a into infinity, so e raised to infinity will be 0, so 0 multiplied by anything will become 0, so this first part will become 0 completely, minus now 0, 0, now in the place of x if we put 0, it becomes e raised to 0. E raised to 0 is 1, so 1 upon a square plus lambda square into again over here minus a. In place of x we have to put 0, 0 into lambda will be 0, so cos 0 plus lambda sine 0. Then what remains is 0 minus 1 upon a square plus lambda square, then cos 0 is 1, so minus a, 1 into minus a will be minus a, then plus this entire thing will become 0 because sine 0 is 0. Then what remains is a upon a square plus lambda. Now this is d by d lambda fs of lambda. So now what we will do is we can take this d by d lambda that side. So then d fs lambda a upon a square plus lambda into d lambda. This d lambda comes this side. So now integrating on both sides, we have to integrate on both the sides. So we will integrate on both sides. D fs lambda is equal to a upon a square plus lambda d lambda. So this side also. So this is nothing over here. If we integrate this, the answer will be fs lambda is equal to, now a we can keep outside, then what remains is integration of a 1 upon a square plus lambda d lambda. So we have one formula for 1 upon a square plus lambda square actually, because I forgot this over here. So we have a square. So 1 upon a square plus lambda square, we have a formula. So I will tell you that formula. So integration of 1 upon a square plus x square dx is equal to, we have 1 upon a into tan a upon x. So this is the formula. So for the previous sum we can write fs of lambda is equal to, a we have kept outside, so therefore a into 1 upon a into tan inverse of a upon x. So then this a and this a gets cut, so therefore fs of lambda is tan inverse a upon x. So this is the final answer. Thank you for watching the video. If you like the video, please like, share and subscribe to my channel for more upcoming videos. In the upcoming videos, I will be taking some more examples on DUIS sums. So stay tuned. Thank you.